Hi everybody, so this video is all about enzyme inhibitors. So there are two kinds of inhibitor, competitive and non-competitive. So if this is our enzyme, the enzyme has an active site, and then somewhere else on that enzyme is something called the allosteric site. And an inhibitor will bind either to the active site or to the allosteric site, depending on what kind of inhibitor it is. So this is the substrate, and we know that the substrate molecule will bind to the active site. If we have a competitive inhibitor, the competitive inhibitor also binds to the active site. So this blue molecule is a competitive inhibitor, and of course if the competitive inhibitor is bound to the active site, while it's there, the substrate molecule is prevented from binding as well, because the competitive inhibitor is in the way. A non-competitive inhibitor, however, binds to the allosteric site. Now, normally we would expect the substrate to be able to go into the active site and bind. However, when a non-competitive inhibitor is bound to the allosteric site, it causes a change in the shape of the active site, so it just distorts the protein molecule slightly. The active site changes shape, and of course when that happens, it means that the substrate is not able to bind. If we look at competitive inhibitors now, we're going to look at our substrate concentration against the rate of reaction graph. So here is our enzyme molecule with our substrate, and if we just look at what happens with no inhibitors present, then we would see the graph shape that we would expect. So we see an increase in the rate as you increase substrate concentration until you get to Vmax, and then from Vmax we can calculate the Km by first of all looking at the half Vmax and then working out the Km, which is our substrate concentration. So this is what we would see when there are no inhibitors present. However, when we have an inhibitor, if you look at what's happened here, the initial rate of reaction is less when the competitive inhibitor is present. And that's because the competitive inhibitor is able to block the entry of our substrate. So therefore, in a given amount of time, fewer substrate molecules are able to enter the active site, and so the reaction proceeds more slowly. If you increase the concentration of substrate, then the rate of reaction still increases, but because you've always got your competitive inhibitor there, which is always able to block the active site, that means that even though you're increasing the substrate concentration, at every point, at any given substrate concentration, the rate is going to be lower with a competitive inhibitor compared to that same substrate concentration without the competitive inhibitor. However, if you keep increasing the substrate concentration, it becomes far less likely that the inhibitor molecule is going to collide successfully with the enzyme, because there are just far more substrate molecules compared to inhibitors. So it becomes sort of just a case of probability. If you increase the substrate concentration high enough, it is so unlikely that the inhibitor molecule, which is at a much lower concentration, that they are going to bind to the active site, that you eventually, with enough substrate, you will reach the same Vmax that you had when there was no competitor at all. It's almost as if the competitor, it's been outcompeted itself. So high enough substrate concentration, you will reach the same Vmax as before. If we look at Km though, you can see that the Km with the competitive inhibitor is higher than without. So Vmax is the same, which means that half Vmax is the same. So if we follow along half Vmax until we intersect with our line for the enzyme with the competitive inhibitor, then we get down to this substrate concentration here, which is our Km value. So this Km, when you've got the competitive inhibitor, is higher than the Km without. So what does this tell us? We know we've got the same Vmax with a competitive inhibitor as without. We know we have a higher Km with a competitive inhibitor compared to without, and that tells us that the enzyme has a lower affinity for its substrate. You need more substrate to reach half Vmax. The lower affinity for its substrate because the substrate is competing with the active site with the inhibitor. Okay, let's have a look at non-competitive inhibitors. So again, we've got our rate of reaction when we have no inhibitor is what you can see here, same as before. But then if we add our non-competitive inhibitor, which is bound to the allosteric site, so our rate of reaction is lower at a given substrate concentration initially. So you can see here, for example, so it is lower than without the non-competitive inhibitor. As you increase the substrate concentration, the rate of reaction increases. However, if you keep increasing the substrate concentration, you are still never going to reach the same Vmax that you had before, because there are always going to be some enzymes which have basically been made non-functional. So there will always be some enzymes which have our non-competitive inhibitor bound to them, and therefore those enzymes cannot be involved in the reaction. So that means that even if you have loads and loads of substrate, not every enzyme is going to be able to be converting that substrate into product, because some of them will always have the inhibitor bound. So that means that at very high substrate concentrations you reach Vmax, but it is a lower Vmax than it was. So here is our Vmax is lower than the Vmax was without the inhibitor. So Vmax is lower, therefore we have a different half Vmax. However, what's interesting is if you look at where our half Vmax intersects, it actually then gives us the same Km. So Vmax is different, half Vmax is different, but the Km is the same with a non-competitive inhibitor and without a non-competitive inhibitor. So lower Vmax, same Km, and therefore with a non-competitive inhibitor the enzyme has the same affinity for its substrate. So the actual affinity of this, so the ability of the enzyme to bind with its substrate is not altered. It's just that some enzymes, when the non-competitive inhibitor binds to them, some enzymes are not able to function. Okay, hopefully that's clear. Just try and remember those key points for each type of inhibitor and you should be okay. Thank you.